All right, we're starting off the second semester with systems of equations, which is going to build on a lot of our knowledge from first semester. That's why we spent one day reviewing just graphing, because we're going to start practicing graphing equations with systems. All right, so first of all, what is a system, or what are systems of equations? Systems of equations are essentially two or more equations. That use the same variables. So we're used to seeing equations with y's and x's. So we're going to continue to use those letters. There might be some problems where we use other letters, but most of our problems are going to deal with y's and x's. So graphically, the point x comma y is where the two lines intersect. Algebraically, the point x comma y is the point that makes both equations true, and this will make sense as we work on these problems. So there are three types of solutions that we're going to see as we're working with systems of equations. The first kind is when you have intersecting lines. So intersecting lines are just lines that cross. And the solution, or the point that makes both equations true, is where they are intersecting. And that's normally going to be a coordinate, x comma y. Other types of lines you'll see are parallel lines, and you'll talk more about these in geometry. But parallel lines are lines that never cross. So in this case, there is no solution, so we put no solution. And finally, the last type of equation you'll see are equations that are the same line. So really, it's the same line just written twice. So that's why I have the solid line and then the dotted line to show you that there are two lines, but they're actually the same. And they have what's called an infinite solution. So the symbol for infinity is this sideways 8, and this tells you that every real number works in both of these since they're the same line. So what we're going to work on is, given a system, you're going to tell me the solution and the equations, and then we're going to go the other way as well. If I give you two equations, you should be able to graph them and tell me the solution that makes each equation true. So let's take a look at the first problem. It says, write the system of equations and identify the solution. So we've got two lines here. We've got this equation, and we've got this equation. So let's first work on writing the equations down for each line. So the first one, we need to figure out the slope and then the y-intercept. So remember, slope is just the distance between the points that I can count on the line. I see 2 points are already made up here. So I'm going down, let's see, 1, 2, 3, 4, 5, and over 1, 2, 3, 4. So my slope is -5 over 4x. My y-intercept there is +3. The other equation here is y equals, this time I'm going up 1 and over 4. So that's 1/4 x, and this one's y-intercept is -3. When graphing these lines, the points where they intersect is the solution. So remember, we use the x-coordinate first and then the y-coordinate. So I want to know what this point is where they're intersecting. So the coordinate there is 4, -2. So what that means is if I plug in 4 into each equation, -2 is going to come out. So -5/4 times 4 is -5. -5 plus 3 is -2. 1/4 times 4 is 1. 1 minus 3 is -2. So your solution is a true statement for both equations. Let's look at another example. Let's come up with the two equations and then the solution where they're crossing. So the first equation, I've got y equals, I'm going to count down 1, 2, 3, 4, 5 over 1, 2, 3, 4 again. So this again is negative 5 over 4 x, and the y-intercept is plus 3 again. So it's that same line we had in the top. The next equation, this time the slope I'm going down and over. It looks like I'm going down 1 over 4. And this time the y-intercept is negative 1. So I have a different equation for the second line. Negative 1/4 x minus 1. Where these two lines intersect is going to be at 4, comma, negative 2. So this one happens to be the same solution, but different systems of equations. The other type of problems we'll see is when you have to graph the lines and figure out the solutions yourself. So this time we give you the equation, you need to come up with the solution. We've got to figure out what our y-intercept is, and then also figure out what our slopes are in order to graph those lines, and then we can find out the solutions. So the first one, my y-intercept is negative 1, so I'm going to put a dot at negative 1. And the slope tells me to go down to 1, 2 over 3. 1, 2, 3. I'm going to stop there, but I'm going to use the point here again. I'm going to go in the reverse so I can have a nice solid line. I'm going to go up 2 and to the left 3. So you can go in the reverse to help you plot your points, and it should fit on that line as you're working. Alright, so using our ruler, let's connect those points and then graph the other line. So the other line, the y-intercept's at negative 4, and the slope is 1 over 3. So I'm going to put a dot at negative 4. I'm going to go up 1 over 3, so I can already see where the intersection is. And I can go in the reverse, down 1 to the left 3, so I get the whole idea of what the line is going to look like. So my solution here is where are they crossing? So the the coordinates are 3, comma, negative 3. That's graphing lines and finding solutions. Let's do the next one. My y-intercept is 2, so I'm going to put a dot at 2. And my slope is 1. There's no number in front of x. We always say it's a 1. So that means I go up 1 over 1. Up 1 over 1. I can go in the reverse. And there's a nice graph of my line. The other line, the y-intercept's at negative 3, so I'm going to put a dot at negative 3. The slope is negative, so it says go down 1 over 4. I'm going to do the reverse. I'm going to go up 1 to the left 4, and now I can see where they're intersecting pretty easily. So it's really important you get the coordinates down, because that'll tell you exactly where the location is of the solution. So the solution for this one is at negative 4, comma, negative 2. And now our last example, we'll do the same thing. My y-intercept for the first line is negative 3. The slope is 1/2, so that means I'm going up 1 over 2. Up 1 over 2. Go back to the y-intercept and do the reverse. Go down 1 to the left 2. Down 1 to the left 2. So there's my first line. Second line, the y-intercept is negative 1. The slope is 3/2. That means I'm going up 3, 1, 2, 3, over 2. Up 3, 1, 2, 3, over 2. Going back to the y-intercept, I'm going to do the reverse. So that means I'm going to go down 3, 1, 2, 3, and over 2. So now I can see clearly where that intersection is again. So my location of my intersection here, where these lines are crossing, is at -2, -4. Remember, it always is your x, your y. Alright, so I have some practice problems for you to work on, and let's see how you do, and good luck.